All right, everyone, welcome back. I was hoping that we could take some time to consider what may be happening in our infrastructure, because the problem is, and I want to really illustrate this again, and that is the fact that on my devices, my R19, R20, and R21 show IP route are not learning any RIP prefixes. Let's go ahead and just clarify that very clearly here with show IP route RIP, and you'll see that we have no prefixes being learned on any of these devices. Do show IP route RIP, or show IP route RIP. Nothing's showing up in the routing table. Now, the problem doesn't extend to anything with regard to RIP other than its basic operation. Now what I'm going to do is on this device, on R20, I'll just arbitrarily pick one. I'm going to type show IP RIP. And what I want to do is, let's see, debug IP RIP. And let's see what happens here. Now we know R5 is learning prefixes that are being advertised by R19, R20, and R21. We were even able to check reachability. Now we also know that we're going to be running our default timer, so what's going to happen here is every 30 seconds we should get some kind of update. And what I want to do is I want to see the nature of those updates. I want to see if we're sending and receiving updates on this device. Notice we've sent an update, a version 2 update. It was actually sent via the tunnel, and it's representing these two prefixes. So that's going to be the 204 segment that we have, and also the loopback on 20. Now, we're going to be waiting, and the idea is that we should ultimately receive something coming from R5. Now, when we look at this, like I said, the main thing is that we have to recognize the fact that our devices are either going to they should send and receive updates. The issue is the fact that we need to understand the nature of these updates. Well, notice right here we have send via V2 update, and again, we're sending, but we haven't received anything. So it's been about a minute, so 2 30-second cycles, and we still haven't received anything from R5, which makes sense when we consider the fact that R5 is learning about the prefixes on 19, 20, and 21. We can see exactly that it's learning it because we're sending that information, but R20 is never receiving anything from R5. And that's where I want to do. I want to go back to R5 and take a look at my configuration. Now, let's do that same debug. So debug IP RIP. And let's see what happens with regard to sending information. Let's see here. Can I? All right, here we're receiving. We received an update through the tunnel. So this is from 20, this one's from 19. So we're receiving those updates. Just waiting to gather up some information, probably about a minute or so here. Okay, you all. Now let's take a look and see what we've got here. I want to scroll up and look at some of these outputs, because notice this is all about receiving updates. I want to see something about sending updates. Well, here we go. Sending a V2 update via 10.10.10.5. That's the loop, the tunnel interface that I have configured on R5. And when I look at this, see, what prefixes are we sending out? Well, we're sending everything. We're sending 222, we're sending 223, we're sending information about the tunnel interface, we're sending information about the loopback interfaces for R2, R1, R3, and we can see all of this information is going out that interface, but the problem is it's never arriving. Well, that begs the question, is it actually going out the interface? Let's look at that. How do I do that? Well, what I'm going to do is I'm going to do a debug. I'm going to say debug IP packet detail. And let's see what happens now. Now we're going to get a lot of output when the time comes. Okay, let's UOL this now. We've turned off our debugging. Now what I want to do is I want to see anything that's being sourced from us that's going out to the IP address that's being used by RIP. So that multicast address is that 224.0.0.9. Now when we go through here, notice it says route packet from tunnel 0, source 21, destination 9. So that's received. So let's see here. We've got IP source from 1, destination 10. That's EIGRP. That's EIGRP. Look here. Route packet from loopback 0, source 172.16.55, destination 224.0.0.9 says packet routing failed. Okay, well, why would our packet routing fail? Well, it really boils down to the fact that this DMVPN that we're working out on is what is referred to as a non-broadcast multi-access environment, an NBMA connection. Now, NBMA says non-broadcast, but we also have to recognize that broadcast addresses and multicast addresses work together to give us our connectivity. Well, let me fix this. I swear I need to get a better idea of where everything breaks here. So allow me just to redo that real quick. So this DMVPN is an NBMA. Now that means NBMA means non-broadcast, but we have to understand that there's a comparison or there's a similarity between broadcasts and multicasts. Now, recognizing this, what we need to make certain is that we need to understand whether or not our DMVPN cloud is going to support the idea of multicast. If it doesn't support multicast, it's not going to be able to carry the messages for RIP across the cloud. Now, what we're going to find is as we advance our discussions, there's going to be another way to get around this. But right now, all I'm going to do is I'm going to enable the multicast capability with regard to my tunnel interfaces so that we can get resolution and get this up and running. So the way I'm going to do that is I'm going to go under the tunnel interface on R5, and what I'm going to do is I'm going to execute the command IP next hop resolution protocol map multicast, and I'm going to tell it what addresses to use to reach different destinations. So for instance, if I go here and set this up, it's going to be multicast, and I'm going to say 10.1. Let's see here. What are my individual addresses? Bear with me just one moment. So this is going to go to S4, so that's going to be 194.19. It's going to be 204.19. And it's going to be 214, not 19, 21. Do show run interface tunnel 0. Let's make sure I got my sums right here. So 2420, 2121, 1919. Yes, that should give me everything that I need. So let's see what's going on now. So let's cut back over to R20 and see what happens. We're sending updates, and notice here we can tell immediately we've started receiving updates, but we'll wait for another refresh to come through. Actually, rather than wait, show IP route RIP. And now I have my prefixes. So I'll go ahead and all this. We don't need to wait for the results. They just came in. Do show IP route RIP. And then on 20, do show IP route or show IP route RIP. And now we can see the prefixes. So let's see if we have reachability. So let's ping 172 16.222.222, and I want to source it from LO0, and I have reachability. Now, what I want to do is I want to return to this idea of split horizon. That's what started this whole scenario. The split horizon command changes the behavior because remember, I said if I receive an update on an interface, I'm not going to send that update out that same interface. In this scenario, that's problematic for us because R19, 20, and 21 are connected to R5 via this DMVP cloud, DMVPN cloud via a single interface. Now, what I had done is I'd went over to R5, show run interface tunnel 0, and what I did is I disabled split horizon. Let's turn that back on and see what the change in behavior is. But first, let's see, can I ping 172.16.20.20? And I can. Let's see if I can trace route to it. To 172.16.20.20. And we see it's going from 20 to 5 to, it's going from 19 to 5 to 21, or to 20 in this instance. Let me double check. Yeah, to 20. Let me U all the debugs here. All right. Now, let's remove the command on R5. Config T, interface tunnel 0, IP split horizon. Do clear IP route star. All right, that should take everything out. Now what I'm going to do is go back over here to R19, 20, and 21, show IP route, 172.16, and let's take a look at 2020 now. Still in my routing table. Notice it says it's 22 seconds in my routing table. Let's see if it goes above 30. Well, that's at 28. Let's see if it goes above 30. Now it's at 31. 33. So we've missed one hello period. So let's not panic until after we reach 60. Well, actually, we're not even really panicking because this is the behavior that we would anticipate. And what I'll do is I just want to see it go above 60. In fact, I'll even execute the same command here. Okay, we're at 54 in some of these a minute. So we are missing pre-updates. So we'll go ahead and let's clear these. So clear IP route star. 19, clear IP route star. 21, do clear IP route star. Let's see if we can see the output for this particular prefix now. So 172.16, let's look for 19.19 this time. Show IP route. It's not in my routing table. Show IP route. RIP. What we're going to find is I have reachability, let's say to 22, 172.16.222.222. I can even source it from my own loopback address, and I have reachability, which means R22 knows about my loopback address. Now, if I come up and say I want to ping 172.16.19.19, I'm not going to have reachability. And here is why. Every prefix that I'm learning about each of these devices that are participating in the DMVPN, I'm learning from R5. And the problem is like I said, it's that split horizon concept whereby now that I've got split horizon on by default in RIP, what's happening is that it's not going to advertise the prefixes that I learned on the interface that's connecting me to R19, R20, or R21 to any of those other devices, because what's going to happen is the fact that that split horizon process is going to try to prevent the possibility of having loops on a single interface. Now, the way we get by this is to go back over to R5 and restore the configuration where it's no IP split horizon. But before we do that, let's just make sure that it had nothing to do with just waiting. Don't have anything for 2020 or 2121. Let's go ahead and enable the split or disable split horizon. And then what will end up happening here is that we're not going to learn anything immediately. Debug IP routing. But we should be able to see these prefixes as they come into our device by virtue of the fact that they're being sent across this serial link. So notice here, it's adding the prefixes. It added the connection. Let's see, it updated the RIP connection for 21, 11, 11. Let's see what else we have here. Now we're learning 20, and we're learning 21. And we're on 19. So just to verify my test, ping 172.16.20.20. What happens if I source it from my loopback address? I'm good to go. And also, I can even do a trace route. So trace route to 172.16. Let's see, we'll say 21.21 this time, just to verify the other link. So never lose sight of the fact that in RIP, our split horizon process is going to be on by default, even in iOS 15 code. We'll learn later on when we're talking about another routing protocol called EIGRP, that behavior's changed in 15 code. What used to be on by default, split horizon, is going to actually be, well, we'll look at it when we get there. It may have changed, it may not have changed. And again, what I want to illustrate to you guys is that no matter what you hear, whether it's me or whether it's another instructor, always verify everything. So the main point here is I was getting ready to say that IP split horizon is going to be off by default in 15 code, and that's not a true case. I was actually thinking of the fact that auto summarization is going to be off by default, which is true. So in 12 code, summarization in EIGRP, auto summarization, was off by default. I mean, it was on by default. Now in 15 code, it's actually been turned off. But again, we need to verify all of this on a case-by-case basis, and you guys need to lab it up and make certain that you understand exactly how these processes operate at the command line as well as with regard to theory. So this clears up or should address the idea of split horizon. I'll see you guys in the next part of the presentation, and we'll continue delving into the operational capabilities of RIP version 2. See you there. Bye-bye.